I'm Avi, and I work for Percona. And today I'm going to speak in the session about upgrading or migrating your PostgreSQL with least possible downtime, right? Especially when you're working on PostgreSQL, which is like a version on a version that is either end of life or a legacy PostgreSQL version. That is when you could kind of get into concerns while upgrading your Postgres. There's going to be a good amount of demo as well while I talk about this. So what we are going to see today is what is the checklist that you might need to follow before the upgrade, right? And at the same time, we would also go ahead and see what are the methods that are available to upgrade your Postgres from one version to another version, and we'll see some demo. So quick checklist. I don't think I have to talk about the checklist anytime, but a good way to introduce. So you would need to plan your hardware specifications of your target server in advance, because if I would like to do that again after the upgrade, it doesn't work well, right? Because I need to spend time again and maybe downtime. Application to DB connectivity. You should also be looking at what kind of connectivity you need to have from your application to DB. Like maybe if you need to introduce some connection poolers or proxy solutions, etc. Right? High availability. You always need to test and plan your high availability in advance before doing your upgrades, because you cannot think of upgrading and then, oh, what should I do? What tool should I use to set up high availability? That is something that you should not be doing later. Performance testing. So all upgrades may or may not give you optimal performance. Maybe that's a wrong statement for Postgres today, but sometimes you may have to code your SQL in a way that, for example, like until 9.6, the way partitioning worked in Postgres was different. Starting from Postgres 10, it's totally different, right? So you may have to rewrite your application logic in a way that it hits the SQLs that can work with the latest partitions, right? And backup strategy. Again, what if it's a terabytes of database server and you run PG best backup and it takes 2 or 3 days to complete, right? Then you don't have a proper backup strategy. Plan your postgres.conf parameters in advance, because when you do your performance testing on an equivalent server as your future Postgres server, right, production server, you would be able to see what kind of parameters are really needed to tune your Postgres server. So plan them in advance. And finally, install all the required tools and extensions that would help you build a right PostgreSQL solution, because just the community Postgres may or may not really give you all the benefits, because at least to perform maintenance activities you need some extension. So you need to plan that in advance. I'm not going to spend more time on this slide, but I'm quickly going to talk about the methods that are currently available. You could use the first 2, or actually 4 of them are available with Postgres community code. You don't have to do much about it, right? pgdumpall. That's the logical backup solution that's available in Postgres today. And pgdump, pgrestore. So this is database level logical backup, and this is total cluster level. A group of databases, because in Postgres cluster or instance you can create multiple databases. If you have got more than one database in your Postgres server, which is on one instance running on single server, serving one port, one data directory, right? You cannot just use pgdump, pgrestore. You have to manage individual pgdump, pgrestore of each database. You could use pgdumpall. Logical replication, that's available as an extension or built into Postgres starting from Postgres 10. Slowney, it supports Postgres 11, like you could migrate from an older version Postgres to Slowney. And PG upgrade, that's something that's available with Postgres by default. It's built in, right? With which you could do upgrade using hard links or even a copy, right? Which could take some time. So we are going to talk about that. I heard somebody behind me. Okay. All right. So now quickly we'll talk about what involves downtime and what does not involve downtime. When I say downtime, do you really have to shut down all your applications while this is happening, right? That is what downtime is, because sometimes when you have to switch your application from the previous version to a newer version, it, of course, that switch or flip does involve some downtime, right? You cannot definitely avoid that. There will be a microsecond downtime at least. However, we're talking about downtime during the process. So pgdump all, pgdump restore does involve downtime. And these are the three solutions that you could always use to avoid downtime: logical replication or PG logical, Slowney one, and PG upgrade. So pgdump all. So quick introduction to pgdump all. If you already, how many of you know pgdump all by any chance? Okay, great. Okay, so pgdump all is a text format dump of the whole database cluster. So it can be used to take backup of globals that are global to the whole database, like users, table spaces, roles, privileges, right? Or you could also dump all the databases. But when you're dumping the database contents or the cluster, right, if any activity is happening on the database server, they are not backed up by pgdump all. So you need to shut down your application and make sure that there are no writes. And you could pipe it to the target, which may be a different server or the same server as the current production server. You could, of course, copy it, but you need to have additional disk space, right? So when you proceed with this approach, you need to have additional disk space. And so if it's a 1 terabyte database server, you need to have another 1 terabyte, right? And that in case if you're doing a pgdump all pipe PSQL to the new server, right? And if you would like to go ahead and take a backup using pgdump all first and then use that backup, which is a text file, to restore to a new server or new version, again that involves much more space, right? It could be a single step approach because you don't have to deal with users, globals, everything separately. Quickly we'll see pgdump, pgrestore. pgdump and pgrestore is something that can be used to take backup of a single database using parallel jobs, right? So you can take, if you have a 16 core machine, you could use pgdump in 16 parallel jobs, right? And take a backup, and you could also pgrestore it, right? So that could be faster. However, pgdump and pgrestore cannot take backup of users and globals, right? So for that, you just use pgdump all -g that just takes backup of users, privileges, and roles, and restore it first in the new server, and then use pgdump, pgrestore in parallel. So that could be a faster. But while this process is happening, your application writes have to be down, right? And even this process involves double the disk space if it's in the same server, which we call in-place upgrade maybe, right? And if it's a remote server, yeah, it involves network, of course, right? But with this approach, even with pgdump all, right, it removes table bloat. So if you have a server that's not well maintained, which is 1 terabyte in size, maybe after restore, it could be down to 700 GB, or it depends on the amount of bloat or wasted amount of space that it has got in it. Now Slowney, and we'll also see a quick demo on it to understand how easy it is. Slowney, to give you a background on it, or maybe how many of you know about Slowney? Great, okay. So Slowney is one of that replication solutions that was available with Postgres even before streaming replication. That was the replication tool that was used earlier when there was no streaming, and it's a trigger-based replication. So that is why we got out of it and we use binary. But the great thing with Slowney is that it can do something that streaming replication cannot do. So streaming replication cannot work between two different major versions in Postgres. But Slowney can even work from 8.4 to 11, right? So you could even upgrade your PostgreSQL running on 8.4, which is totally a legacy version, to 11. How could you upgrade? Because you just need to configure replication between the PostgreSQL 8.4 and PostgreSQL 11, right? So for that, you need to go ahead and use the Slonik scripts. The setup is pretty simple, and it would need to first create the empty schema, because you need to have those tables created, and then copy the data and create triggers and enable the replication, right? So these triggers track the changes and continuously replicate the changes that are happening while the application is still writing during the copy of data. Okay, so once you know that the continuous replication has been set up, that is when you would go ahead and quickly stop your application, point it to the new server. Let's quickly see that demo. We have gone ahead and made it pretty simple to you know, I mean, I would not be running anything that's like manual here, so let me, yeah, okay, great. Okay, so I'm going to connect to, so this is the server that's running on Postgres 8.4.9, as you could see, right? And okay, and this is the server that's running on Postgres 9.4. Okay, I'm sorry, 11.3. Okay, so here we got a table, I mean a database called PGBench that has got some tables in it, and right, even in this one we got, right, a database called PGBench, but it's empty, right? So what I'm going to do now is I'm going to I've actually automated a lot of stuff.
Can you do it at the cluster level?
No, you have to do it database by database. Yes, you cannot do it cluster level. You have to have multiple Slonik daemons in order to do it multiple databases, right? So so what I'm going to do now is I'm going to go ahead and run a, I hope everything works out with this network, but so what it is initially doing is it checks, I mean this is a simple script that you should also be, I mean anybody could automate it if you know how to do it, but so we need to make sure that we have, we check if all the tables have got a primary key, because if your table in Postgres 8.4, the source table has got no primary key, then that cannot be replicated, because to track the changes when we create trigger, it should be able to identify a unique record using a primary key. So a primary key is a must when you are replicating a table, because it's a table by table replication. So it's a group of tables that are being replicated from source to target. Source is 8.4, target is 11, right? So first you need to make sure that all the tables have got primary key, so we kind of could grep and check, okay, yeah, we have the constraint that says primary key, right? All the tables have got primary key, and then we need to configure users and remote access on the new server and copy the new schema, right? That's pretty important, because that's something you could just do using pgdump-s, right? That just copies the DDL, only the schema, not the data, right? Once that is done, right, yeah, I mean don't worry about the errors, because these tables actually I should have dropped them, but I'm just running them on top of it, so it should just ignore. Okay, and now I just need to go ahead and run the Slonik init script. So what I would do is, yeah, so on both the servers we need to have Slon daemons that should be running, and these daemons go ahead and send the data that it identifies to the other daemon so that the data can be replicated, applied, right? So what I'm doing is I'm just checking if in case, you know, it's just a simple test to see like how much of data we got on this T1 table. Is just one record that we got, and on the slave it has just got one record. So we'll kind of go ahead and insert another record maybe, and that will be 1 and 3, but expect some delay in replication. It's not as fast as streaming replication. in Postgres, right? So you should definitely expect, but at some point of time, yes, it got that data replicated, right? So here it's connecting to the master, which is 8.4, and here it's connecting to the slave, which is 11.3, right? So likewise, in the future, let's say while this replication is happening, if somebody wanted to add more tables, you could of course do that, right? You could just do set add table and give an ID to it, okay? And once you're ready to switch your application to the slave, which is nothing but the Postgres 11.3, you could just go ahead and drop the nodes and remove the Sloanie configuration, because it creates some schema and tables that would capture the changes. I'm not, as this talk is not more about Sloanie, I'm not getting into more details of it, but, and that's why I had to automate it, right? But what I mean to say is there is an option called Sloanie that could get you away from even an older version Postgres, right, to a newer version Postgres. And now, right? So you would be able to monitor the replication health checks and write scripts on top of it so that things can be automated, the replication, right?
Say you're doing the replication and you figure that, say, maybe data corruption or there's an issue with data and you need to roll back. What do you do?
So I would need to go ahead and stop the Sloanic daemons first and then see where is that issue, right? Firstly, I need to fix that issue. And then I could restart the Sloan daemon so that it could continue. So I need to fix that corruption issue first. If I know that that is something, usually when that happens when you're upgrading, right? If I were you, like, I would terminate that completely and I would try to restart everything unless I know that nothing has been disturbed until whatever has been done.
So let's say the data has been corrupted, has already gone in table or whatever that's holding data has already been replicated to the upgraded version. Can you do a reverse replication back from, let's say, from 8.11 down to 6?
Okay, so what you're talking about is after the upgrade.
Yes.
Okay.
While your upgrade is running at this time, you notice, oh, we need to reverse this because of XYZ. Can you?
Yes.
Is it going to be the same process?
Yes, it's just the same process. You can also do 11 to 8.4.
Okay.
It's only one direction, right? It works only one direction.
It's not bidirectional, but what he means to say is, like, the upgrade is completed and after that the Postgres 11 is ready, so you stop your Sloanie, right? After that, to be careful, you know, you could set up from here to here, right? It's a fresh setup again, but a reverse.
Okay. But there's
Right?
no bidirectional.
No, there's no bidirectional now.
Okay.
Yeah. Okay. So there's another replication method which is logical replication, right? That's built into Postgres 10.x and 11. However, if you are using Postgres 9.4 and you would like to get to the latest version PostgreSQL 11, the same logical replication, right? I wouldn't say it's same, but there are, I mean, it's just an extension of the PG logical extension that's that's available with Postgres 10 and 11. So you could go ahead and use this PG logical extension that's available even for 9.4. How many of you would have heard about, I mean, how many of you heard about DMS in AWS? Data migration services, okay, right? So DMS internally uses PG logical when you need to upgrade from an older version to newer version Postgres, which is migrating to RDS, let's say, right? So you again need to have primary key for the tables to be replicated and maybe a few minutes of downtime. Quick, very quick demo, not much time, right? So I have okay, so this is much more simple. This is much more simple to set up, no doubt in that. Come on, okay, yeah, right. So I have Postgres 9.4 here, and I have PostgreSQL 11 here, right? Okay. Yes, 11.3, and here it is 9.4. So I just need to have this PG logical extension installed, and once that is installed, I would first need to create, the server that is sending the changes, right, is called the publisher, right? So this is the publisher node. So I need to create a node, right, which is a provider node on the publisher, and I could just go ahead and add all the tables or just add individual tables for replication. Okay, this is just the thing that I could do here, and I could later run some selects to see if the node is created. This is on the source 9.4, and see what tables are added for replication. And on the target, I could just go ahead and create another database, which is a subscriber. I'll again create node. So this time it's a subscriber. I name it, and I'll just create a subscription. That's it, right? And here you see that it's the provider node is pglogical94, which is the host name, port number, database name, and the user and password using which it needs to connect to that node, right? And now if you would go ahead and select count of star from pgbench accounts, and let me, so here I didn't even have to go ahead and create these tables. I was able to say synchronize structure. That means copy the DDL from the source. So pglogical just did that. It's just 4 steps to upgrade, right? So once this is continuous, once it copied all the existing data and also set up replication, everything has been set up, you would then go ahead and turn off your application and then repoint it to the new node, right? It's pretty simple. And the last and the final one that I'm going to talk about is PG upgrade. That's available built in with Postgres already, and you could use the hard links option, which would do, which would actually go ahead and do the upgrade in place without needing double the disk space, right? So hard links option can be used, which would just work with the inodes, and but however it would not take into effect such as bloat or fragmented space. All that would not be gone, but that's one of the most easiest and the fastest option. You just need to install the latest Postgres binaries and use the latest PG upgrade and say PG upgrade -k, right? That's the option that you could use for using hard links. You could just upgrade it on the fly. It's just a few seconds of upgrade, right? It takes a few seconds, and you could just go ahead and proceed with the migration. So these are a few of the methods that you could use to upgrade your Postgres. I'm so sorry. In the interest of time, I could not do much of a demo on everything else, but yeah. So well, thank you again, but you could definitely go ahead and look at all these options in case you would like to go ahead and upgrade. But you could search my name and you would see all these blog posts, which are much more clear, right? In case you need to set it up. Or you could add a comment there so that we can help you with something else if needed. Yep.
Does the PG upgrade need all the tables to have parameters?
Not needed. Really not needed. It's totally blind. Like you could just go ahead and say PG upgrade, and it would go ahead and it works with the file descriptors, and internally it points the new files to the inodes of the existing and just create some more extra tables internally, and all that just happens on the fly. Like I was able to upgrade a 3.5 terabyte database server in 10 seconds using PG upgrade with hard links, right? So, but it only works when you're doing that upgrade on the same file system. And if you would like to use hard links within 2 different file systems, no, it doesn't work. So you need to be on that same file system. Yeah.
Can you use PG upgrade for multiple version upgrade, like the 8.4 to
Yes, yes, using the hard links.
I have a question about Sloney. So my database runs in AWS RDS.
Mhm.
So where do I install the Sloney daemon? And is there any extension library I have to install on the RDS side?
Unfortunately, you could only use PG logical, but not Sloney if it's an RDS.
Okay, so I cannot use Sloney.
No,
Okay.
you cannot. Yeah. All right. Okay. So thank you, and you could definitely go ahead and rate my session if you like. But yeah, okay. All right, thanks.